Show that the limit of 1 over x squared as x approaches infinity is equal to 0. Solution: let epsilon greater than 0 be given. Our goal is to find a number m such that for all x's, wherever x is greater than m, it implies that the difference between f of x and the limit L equal to 0 is less than epsilon. Again, we work out this inequality. Or 1 over x squared is always positive. We can take off the absolute value and we'll just have 1 over x squared less than epsilon. Taking reciprocal of both sides, we'll have x squared is greater than 1 over epsilon. And now we take the square root of both sides. Okay, and when we take the square root of both sides, this leads us to the absolute value of x greater than 1 over the square root of epsilon. And what does this absolute value inequality mean? It means that either x is greater than 1 over the square root of epsilon, or x is less than the negative of 1 over the square root of epsilon. So what do you think is our choice of m? We choose m to be 1 over the square root of epsilon, so that for all x is greater than m, then how about if we change that color? Then absolute value of 1 over x squared is less than epsilon. And in the same way, based on this inequality, what is our choice of n? We choose n to be equal to negative 1 over the square root of epsilon, so that for all x's less than n, then 1 over x squared will also be less than epsilon. Okay, so we've proved that the limit of 1 over x squared as x approaches plus or minus infinity is equal to 0. Infinite limits, a precise definition. Okay, we say that the limit of f of x as x approaches x of 0 is equal to infinity if for every positive real number b, there corresponds a delta such that for all x's within the neighborhood, okay, for all x's close to x of 0, close enough that they are less than delta, it implies that the y values would be greater than b. We say that f of x approaches negative infinity as x approaches x of 0, and that means we take the limit of f of x as x approaches x of 0, and it's equal to negative infinity if for every negative real number minus b, there corresponds a delta such that this inequality means that they are within the delta neighborhood. The x's are within the delta neighborhood would imply that the f of x's will be less than negative b. And infinite limits, remember, that are what we use when we try to find infinite limits, is what we use to determine whether a graph of a function has a vertical asymptote. If we take a look at this graphical representation, suppose we let b greater than 0 be given, and we work out our way and find an interval that contains x of 0, and again we choose a delta neighborhood so that for all x's within this band, we see that all the y's will be above b. In the same way, if we let b or minus b be a negative number, then again we find a delta around x of 0 so that for all these y values, for all x's within this neighborhood, all these y values will fall below negative b. Here is a function that we looked at earlier, f of x equal to 1 over x squared. Okay? And we see from the graph that the limit of 1 over x squared as x approaches 0, both from the left or from the right, is positive infinity. How do we show that the limit of 1 over x squared as x approaches 0 is plus infinity? Let's just take the limit as x approaches 0 from the right. And again, to prove this solution, let b greater than 0 be given. And our goal is we need to find a delta so that for all x's such that x in absolute value x minus 0 less than delta implies that f of x is greater than b. In this particular case, it would imply that 1 over x squared is greater than b. So how do we find our delta? Again, we work backwards. We look at the inequality 1 over x squared greater than b. And taking the reciprocal of both sides, we'll get x squared. So if 1 over x squared is greater than b, then taking the reciprocal would reverse the inequality so that x squared now is less than 1 over b. Taking the square root of both sides, we see that x is less than 1 over the square root of b. And notice here, that is our inequality that we want to satisfy. And so our choice, okay, so our choice of delta would be 1 over the square root of b. If we choose delta to be equal to 1 over the square root of b, then for all x is such that absolute value of x less than 1 over the square root of b implies that the absolute value of 1 over x squared will be greater than big B. And from the graph, if this is equal to, if suppose this is our b, okay, so y is equal to b. If I solve for x, I will go down here and I will get x to be equal to 1 over square root of b. So that's going to be where you will find a delta neighborhood. That's our delta neighborhood. So that for all x's close to 0, our y values, all these y values, will be greater than b, both sides. But here we just took the limit as x approaches 0 from the right.